Hi, everyone. Okay, so this was the information that I was going to, the lesson, not information, that I was going to do on February 2nd, which is Tuesday's Google Meet. I have now decided to make a video of it, so you can print it out in the Google Meet. If you go to the Google Meet folder for February 2nd, these two PDFs are there. I've decided just to kind of go through and go over those with you. And then what will be due midnight on February 3rd, because you have an asynchronous day tomorrow. You will watch this. You will do the 5.2 worksheets and upload those. And then you will watch the 5.3 video notes and upload those. Everything will be due by 2/3 tomorrow night. So if you have any questions, please let me know. But if you want to print these out, that would be great. You can pause the video and print these out and then go along with me, or you can kind of just take notes on your own. You do not have to upload this part. So what you are uploading for an assignment is the 5.2 worksheets. That is a classwork grade, which is more than a homework grade, so make sure you get those 5.2 worksheets in by midnight. And the other thing that is due is 5.3 video. I will put all of this in a 2223 asynchronous folder for all of you. Okay, so here we go. Let's wrap up simulation. I wanted to do one more simulation with you. A basketball announcer suggests that a certain player is a streaky player. That is, the announcer believes that if the player makes a shot, then the player is more likely to make the next shot. As evidence, the announcer points to a recent game where the player took 30 shots and had a streak of 10 made shots in a row. Is this convincing evidence of a streaky shooting by the player? Assume this player makes 50% of the shots and the results of the shot don't depend on the previous shots. Okay, so it says, describe how you would carry out a simulation to estimate the probability that a 50% shooter who takes 30 shots in a game would have a streak of 10 or more made shots. All right, so we're going to look at what one trial is. We're just going to set it up. We're not going to do it, but we're just going to do the setup. So we are simulating, right, that the shooter takes 30 shots in a game. What is the probability that they have a streak of 10 or more in a row? So I'm going to make a little text box here. This is Cami if you've not used it. Let me just miss that. Sorry. Okay, so we are simulating a probability of making 10 shots in 10 or more shots in a row, okay, when looking at 30 shots. Okay, so one trial is 30 numbers. We use each one to make 30 numbers. So one trial is 30 numbers. A success is 10 or more in a row. I should have set up my chart first. You know, I always like to do that. So I'm going to say that the probability is 50%. So I'm going to say evens or odds. So evens. So I'm going to say evens is my success. And I should have done my little chart first. So that's that. All right. So we can repeat because each trial is independent of each other. And don't ignore any numbers. Okay, let me go over here and let me draw. This is what I was telling you. If you have not been using Cami, I would strongly suggest using Cami. You can pull up these PDFs and write right on them if you have a touch screen. So, oh, what was that? That's probability. Sorry. I was talking and not paying attention. I was setting up a distribution. Okay, so we are going to either make or miss. And I said I was going to use evens, so I'm going to use evens and odds. You could do anything. You could do odds and evens. You could do this as 0 to 4 and misses are 5 to 9 and flip it. You can do a whole bunch of different things as long as you maintain that probability of 50-50 because his shooting is 50-50. Okay, so let's take a look at let's take a look at down here where it says the dot plot displays the results of 50 simulated games in which this player took 30 shots. All right, so number 2, it says indicate what these mean. All right, so this is each one of these dots is one trial of 30 shots. And they counted up how many in a row. Sorry, that's I'm doing this from home, so that was the garbage truck. So one trial is 30 shots. Each one of these is 30 shots, and this is how many they made in a row. So what do 2 dots above the 9 means? It means that, go to my text box, in 2 trials, because there's 2 dots of 30, a player made 9 in a row. Okay, so that means in 50 trials, a player made 9 in a row twice. Each dot is one trial of 30. Each dot is one trial of 30. There's 50 dots, so that means in 2 of the trials, 2 of the dots, so 2 trials of 30, they made 9 in a row. All right, so the whole thing was, a success was 10 or more. So it says, what conclusion could you draw about whether this player was streaky? Okay, so that means more than 10 in a row. All right, so let's take a look at this. Let me change to red. In only one trial out of 50 did that player make 10 in a row. 1 out of 50 is 2%. So out of 50 trials, that player only made 10 in a row 1 out of 50 times, so 2% of the time. So let me write the sentence, conclusion sentence for this, and then see if you can figure out what I'm saying. There is a 2% chance of getting 10 shots in a row, right? There's a 2% chance of getting 2% chance of getting 10 shots in a row based on a true free, I'm looking at my screen, based on a true free throw percentage of 50%, right? So based on our simulation, we have 1 out of 50 times, which is 2%, of getting these 10 shots in a row based on a true free throw percentage. Typo, sorry, I was typing really fast. I'll clean that up. All right, better. Percentage of 50%. Let's read this sentence again. This is super important. There is a 2% chance of getting 10 shots in a row based on a true free throw percentage of 50%. Does anybody recognize that sentence? Hopefully, if we were online today, that you would understand this. This, if you remember, this is p-value from when you did hypothesis testing. It is basically saying if your hoe has a true percentage of 50% free throw, you are only going to get 10 shots in a row 2% of the time. That's what p-value is. It's just telling you the probability of getting your sample based on whatever your null hypothesis, your HO is. Okay, so that's a p-value sentence. There's a little link there between that and your hypothesis testing. Okay, so that wraps up simulation. The next thing that I'm going to move on to is section 5.2, which you've already watched the video on it, and then I'm going to go over some Venn diagrams because that part of that section is new. The other parts are not new. I'm going to go over that section, and then what you're going to do is the 5.2 worksheets, upload those for classwork grade, not homework, so it means more, and then you're going to watch the 5.3 video. Okay, so Venn diagram. Make this a little bit bigger. All right, so Venn diagrams, and it says section 4.4, but just ignore that because I teach out of like a whole bunch of different books. This is really 5.2. I've taught this course out of like 4 different books. So anyway, so we're going to do Venn diagrams now. Venn diagram. If two things are mutually exclusive, the Venn diagram would look like this. They have no outcomes in common. That would be A and that would be B. The union of those two, A union B, that just means or, is just probability of A plus the probability of B. You just add them together. They're mutually exclusive. They have nothing in common. That's the union. Now, if they're not mutually exclusive, and remember we called this in AP disjoint. In regular stat, you called it mutually exclusive. AP likes disjoint. And I like disjoint because they're not joined by anything. Now, not mutually exclusive. They look like this. So the probability of A plus the probability of B, you have this little area here. The union of that, when you do it on paper, looks like the union A union B, looks like probability of A plus the probability of B minus this and part where it's both in A and B. Remember, that's the symbol from the video, and. So this is your or symbol and this is your and. So let's write that down at the top. So or is going to look like this, and is going to look like this, the intersection. Remember, it looks like an A. Okay, so that was in your 5.2 video. Okay, so let's try a couple problems. A survey suggests that 76% of teenagers use Facebook, 24% use Twitter, and 15% do both. Okay, so we're talking about Facebook and Twitter. So I make a circle for Facebook. I make a circle for Twitter. And I always do this part first. So 15 do both. So 15%, I'm not going to put the decimals in at the moment. Okay, let's go back up to Facebook. This seems like it would be the reverse, doesn't it? So 76 is total Facebook, minus 15 would be 61. So total circle is 76, but there's my overlap of 15. Let's use Twitter. 24% use Twitter. 24 minus 15 is 9%. I'm just leaving these as percentages for right now. You can change them to decimals if you want. Now, every Venn diagram has to be 100. So if I add these up, then the outside of this that don't use either Facebook or Twitter is 15%. All right, so there's my Venn diagram. Find the probability that the student uses Facebook or Twitter. So Facebook union Twitter. Okay, so I can do it 2 ways. I can just add these up and say 61% plus 15% plus 9% equals 85. Or pretend you don't have the Venn diagram. So if you don't have the Venn diagram and you're just looking at it as a formula, you would do percentage of Facebook, 76, plus percentage of Twitter, which is 24, minus, and then we always do both, minus 15. Either way, you get 85%. So this is doing it. Oh, there's the golden retriever bothering me. She thinks I'm talking to her all the time. There's the Venn diagram way, and here's the formula way. Probability of Facebook plus the probability of Twitter minus the probability of Facebook and Twitter, the both. That's that symbol for this right here. Okay, next one. We haven't done these givens a lot, but I'm going to show you how to do it right now. So it says, given the student uses Facebook. So that's all I'm giving you. Let's see, highlighter. Okay, so given Facebook. So that's all I'm given. So everything else in this problem disappears. Okay, everything else disappears. My denominator becomes 76. That's all I'm giving you. Okay, it's just that. It says given Facebook. What is the probability they use Twitter? So we're only going to look in this yellow. Where do I have a Twitter? Right here, 15%. So it's 15 over 76%. And that gives me 19.7%. Let me go over that again. This is a given, so that means that's all you're given. Everything else disappears. So all of this disappears because I'm only given what's in yellow. So given Facebook, 76. What's the probability of having Twitter? Twitter right here, inside that yellow, is 15%. All right. So I want you to pause the video and try this. Read the problem, try it, and then see if you can make your Venn diagram and then use it to answer these 3 questions. And then restart the video and see if your problems are right. Okay, here we go. I'm going to go through. Make my Venn diagram. My Venn diagram is going to be Max and PC. So I'm going to do PC is, I don't know why I did PC first, but anyway. And then Mac, this part doesn't matter. 43, use both, so that's 43. So PC total is 80 minus 43 is 37. Mac total is 60. 60 minus 43 is 17. If I add these up, what's left? For neither, I don't know what they would use if they don't use one or the other of those, but whatever. Okay, so find the probability a person uses a Mac but not a PC. All right, let me go to my highlight again. So highlight, here's my Mac, people. Okay, find the probability that a person uses a Mac and not a PC. So in here, where is it in this blue that I use a Mac but not a PC? Right here. So the answer is 17%. Oh, sorry about that. Okay, what is the probability the student does not use a Mac or a PC? And we talked about that. That's neither. So that would be neither. So that's out here. I don't know what they use. And then the last one, given the student does use a computer. Okay, so that means it didn't say what kind. So on this one, your highlight is all of this. So given they do use a computer. So given they use a computer was 97%. So that's a 97%. Now there goes the plows by. Sorry, it's so loud. So given they use a computer, so it could be any of this. What is the probability that it's a PC? Okay, so where's my PCs? My PC is this. Didn't say they didn't use a Mac. They just said that they used a PC. The people that used a PC is here or here, which is 80. So given they use the computer, probability of PC, 80. 80 divided by 97, 82.5%. Okay, so several things that I'm going to make in your list for your folder of 22 and 23 is, first of all, I forgot to mention this before, is check your 5.1 worksheets. I uploaded the answer key in the homework folder. Watch this video. Upload the 5.2 worksheets and then watch the 5.3 video. And just send me a message on Schoology if you have any questions.